An important part of understanding fractions is being able to recognize fractions as part of a set. In 4th grade, a model that students are frequently using is the egg carton diagram. If you'd like to experiment with this at home, you're welcome to use an egg carton that fits 12 eggs, pieces of string, and maybe hard-boiled eggs so that they don't break, or any other object that fits into each section of the carton. The students begin by exploring fractions of a set. So they might be asked to split this egg carton into 2 pieces. They could draw a line here saying that each of those is 1/2 of the egg carton, or 6 eggs is half of the egg carton. It's important to understand that in fractions, our whole isn't always one thing. It can be a group of things. We can split a class of 20 students into halves or fourths, just as we can split 12 eggs into halves, thirds, fourths, sixths, or twelfths. So there's 1/2. Then students might be asked, okay, how do you split this carton into 3 equal groups or thirds? And they can see that there's 4 eggs in each section. Students are also encouraged to see that with groups, we can split them in different ways. A half might be up and down like this, or it could be across like this. They're the same amount though because 6 eggs fits in each. As students progress through this model, they might be able to model different fractions. Let's say that we want to show the model of 1/3. 1/3 of the egg carton is full. First, the students might use string to see that we can split the egg carton into 3 even pieces. Even groups is the basis of division as well as fractions. Then the students can fill one of those groups. 1/3 of the egg carton is full. Students might be able to model other fractions, such as 1/6. And they also can see equivalent fractions. Let's try building 2/6. Okay, 2 of these 6 pieces are full, but I can also see that this area, 2/6, can also be thought of as 1/3. We can begin to write equations. 2/6 equals or is equivalent to 1/3. In 4th grade, students aren't expected to add fractions with unlike denominators that have the number on the bottom different, that are different size pieces, but this model helps them to start the preliminary steps to do that. Let's say we have a problem about collecting eggs. We have different kinds of hens and they're laying different amounts of eggs in the morning. So we might say that a student went to collect the eggs and filled up 1/3 of the carton with green eggs. Use your imagination. So students might see, okay, this is 1/3 of the carton. I split it into 3 even pieces and 4 of the spaces are full. Okay, we used 4 eggs. So if we're writing this in equations, we could actually see that this is 1/3. However, 1/3, if we think about it as the eggs, is actually the same as 4 out of 12, or 4/12 of the carton. Then they went back outside and discovered that the other chicken had laid 1/6 of the carton. There's enough eggs from the other chicken to fill 1/6 of the carton. But again, from filling up the carton, I can see that 1/6 is the same as 2/12. So then we can ask the question, how many eggs do you have in all, or what fraction of the carton is full? The students can clearly see that if we add these two, we end up with 6 eggs total, or 6/12 of the carton. And many students will also be able to see that 6/12 is the same as 1/2 of the carton. Using models like this allows students to make sense out of equivalent fractions, comparing fractions, and seeing fractions of set. And it builds understanding around how we add and subtract fractions with unlike denominators.